Hello guys, today we're taking a shot at Java garbage collection because it is a mystery to almost everyone involved. It's a complex activity collecting the garbage, and Java handles memory in strange ways. We've all seen exploding memory needs, right? Here's a little test program. No, this is not the test program. This is a test program. There's some preparation, it logs its output, blah blah. Here is the main part. This just makes a lot of IDs. I made up a system for global IDs. It's 16 character random strings. And what I want to test here is if I make really a lot of these IDs, whether there's any collision. You know, statistically there could be a collision, but it's very unlikely because 26 to the power of 16 is quite big. I'm making 100,000 IDs here in one go, adding them to a hash set and just checking if there's any collision. So chances are there is no collision. This is the main loop, and then after each time it throws away all this hash set and it counts what it has done, and if you want it makes a garbage collection. We'll get to this later. So if we run this little test program without the explicit garbage collection, let's check here, run it. Something funny happens. JavaX starting up, blah blah blah. It makes the IDs without collision, pretty fast too, it's all very nice. But look at this here. Now in JavaX in the latest version I always show the memory used. This is the actual used heap. This is the reserved heap. You see it just went down because JavaX makes an occasional garbage collection. But when this garbage collection is not run explicitly, look at what happens here. The RAM used, this is the Java heap, the actual objects. There's some overhead too. So we have maybe 300 megabytes of total use. And the point is that it's not needed. This loop here, it forgets all the IDs it makes in the next run. But the garbage collector just acquires more and more and more memory. I made a feature you can click here to garbage collect, boom, and then see what actually is used. So little memory. Another feature here, you can see it up here, one short line in JavaX. If you start the same program twice, it will have another mode, then it will set this flag here, AutoGC, and it will make a garbage collection, explicit garbage collection, after each run of the loop. Let's check out that feature. Oh, maybe it didn't notice my click, I don't know. This machine is not the fastest one on Earth. Here's the second instance. Let's compare the two. They will have the same result, but let's look at the memory use. This one makes a garbage collection after each run, and look how little memory it uses. I've seen something like 64 megabytes here, but never more. And this is the automatic version. It grows. The same thing on Linux. It grows on 64-bit Linux. It grows to almost 1 gigabyte. It grows to 950 megabytes of Java heap. What are the options we are using? They are these. I use the G1 collector, which is the new and latest and future collector. I think we should be using this because we want a garbage collector that compacts memory, that returns memory to the operating system, right? We really want this because everything else makes memory leaks. So I think there are two to choose from: this G1 collector and the CMS, concurrent mark and sweep collector, which is more for server environments. I think this is the one we should use because this collector has these two options: min heap free ratio, max heap free ratio. It means that we always want at least 10% of free heap, and at most 30. If there's more than 30, it should compact and return memory to the operating system. It does do this, but you know what I found out is that this G1 collector, it needs a trigger. And this is actually the secret to Java memory collection. Some people tell you they should never call GC. GC means runtime, no, system.gc is in Java. In JavaX I only say GC. Calling the garbage collector explicitly. In this case it takes like 100 milliseconds, a little more. Maybe the whole program is a little slower, but it has reasonable memory usage. This is really, really okay. The other thing is not okay. Boom, 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 and it grows, and you don't know why. We don't want to limit the heap to some fixed amount because that's so hard to determine. It might not fit the application. Sometimes it needs more, sometimes less. I don't want to limit it, but I want it to be managed properly. So this is not acceptable, but this here is. So the secret actually is to do regular calls to system.gc. And use the G1 collector and these nice options here. You know, I'm really glad I put this indicator here in JavaX because it shows you what's going on. It was such a mystery before Java heap management and large heaps and heap overflows and too much virtual memory use, which is another weird topic. But for practical purposes, this can be tackled. So Java is strange sometimes, but with the right tweaking, we can make stuff work nicely. By the way, these global IDs that I'm making, they have a very important use for ontologies, for concepts shared, for making a language to talking to artificial intelligence. I will show you this really soon. For now, let's observe this and be really happy that we have proper Java memory management. Spread the word. In JavaX, you only need to run this program once. It sets the global options for programs that are run. And otherwise, it uses the default for the VM, which is usually not that good. These are very good options for really practical use of Java programs. Run this once, and your JavaX will be really, really tuned. Also, there's another program. It's called Update JavaX. Because the JavaX core changes from time to time. If you run this, then you will get the latest version on your machine. You might need to restart the programs afterwards. Click the restart buttons twice. This compiles and makes and installs the latest version of JavaX. I can show you that for a moment, maybe. Because we ain't got anything else to do. Update JavaX. Maybe I need to pause some stuff here. This machine is single core. Look at what I'm working with. Update JavaX. It does a little bit of stuff. It's all automatic. And when it's done, you will have the latest version of JavaX on your machine. Compile, 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 making jar. It makes this glorious 2 megabyte jar. And that's all it is. Afterwards, sometimes the kill button doesn't work, but pressing it twice does work. A little quirk is not so bad. So next thing I'm going to do is, here's a nice picture of garbage collection in Java. Next thing I'm going to do is make these ontologies, these distributed ontologies for artificial intelligence. This is going to be really good. Expect more videos. Have a nice day.